Hello everyone, greetings from VNR, JYOTHI Institute of Engineering and Technology. This is Manohar Reddy, Department of Cybersecurity, Data Science and AADS. In this session, I am going to explain you the concept of sliding window protocol and go back N ARQ mechanism, automatic request mechanism. So the sliding window protocol and go back N ARQ protocols both comes under the data link layer to control the flow of the protocol data transmission. The sliding window protocol is a flow control protocol that allows the sender to transmit multiple frames. So whenever the data is transmitted from the data link layer to physical layer, the data will be converted into the form of frames, right? So here the sliding window protocol is the flow control protocol that allows the sender to transmit multiple frames before receiving any acknowledgement. So in the data transmission, by sending multiple frames, by sending each and every frame, you will get the acknowledgement. You will get the acknowledgement from the receiver side. So here in this protocol, it allows to send multiple frames before receiving acknowledgements. It prevents the sender from overwhelming the receiver and improves the channel utilization. So before going to sending all the frames into the receiver side, it gets an acknowledgement. From the receiver side. So it prevents the sender from overwhelming the receiver and improves the channel utilization. That means it does not provide all frames to be simultaneously sending to the receiver side. By receiving the acknowledgement only, it sends the number of frames to the receiver side. So unlike the stop and wait protocol. So stop and wait protocol works whenever the frame is sent to the receiver side. The receiver send an acknowledgement that he received. So receiver send an acknowledgement that he received a frame 1. Similarly, again send frame 2 to the receiver side. Again he will get the acknowledgement. Again he will send the frame 3 to the receiver side and acknowledgement he will receive. So by sending each and every frame and by sending each and every acknowledgement, it takes lot of time. If any channel delay, if any network delays, then the sender is not able to transmit, right? So unlike the stop and wait protocol, where only one frame is sent at a time, the sliding window protocol permits several frames to be in transit simultaneously. So that can be sent more than one frames. That can be either 3 or 4 or 5 something. That can be able to, based on the window size, it can be sent simultaneously. So what is the need of this protocol? Suppose the sender sends one frame and wait for its acknowledgement before sending the next one, the sender frame 1 receiver. So receiver sends an acknowledgement for frame 1. Again sender sends frame 2 to the receiver. Receiver send acknowledgement for the frame 2. If the network delay is high, if the transmission delay is high, the sender spends most of its time waiting. Yes or no? So the sender has to spend most of its time for the receiving sends an acknowledgement. If the receiver not able to send acknowledgement by the delay of the network delay or transmission delay, he should wait for the longest time. That means it wasted the time, and which wastes the bandwidth also. Because no acknowledgement is receiving from the receiver side, no frame is receiving from the sender side. So at that time, the sender or receiver wasting their time, right? Yes or no? So similarly, the channel bandwidth also wasting. So to overcome this problem, the sliding window protocol was introduced. In this, we can able to send multiple frames. Depending upon window size. We can able to transit multiple frames. So here the sender maintains a window and he specifies the window size. The particular window size. So which specifies how many frames can be transmitted without waiting for an acknowledgement. So the term without waiting for an acknowledgement. So he does not bother about acknowledgement. He directly transmitted the number of frames. The number of frames may be the more than one, right? So by sending that all the frames, after sending all the frames, the receiver send an acknowledgement. So here, for example, the window size is 4. That means the window size is capable of sending 4 frames only. So these are the frame 1, frame 2, frame 3, frame 4. These 4 frames are sent continuously without expecting any acknowledgement from the receiver side. Without expecting any acknowledgement from the receiver side, the sender sends multiple frames simultaneously. After acknowledgements are received, the window shifts forwarded. The window slides are forwarded. That window shifts are forwarded. That means 4 frames are forwarded, and now the receiver sends an acknowledgement that 4 frames are received. So now window again shifted to the next frames. Frame 5, frame 6, frame 7, frame 8. That means the window shifts are forwarded the next frames. It is ready for sending the next frames because it receives an acknowledgement that 4 frames are received. 4 frames are received. So here the components. What are the components of this protocol? The first component is what? Sender window. The first component was sender window. Sender keeps track of the frames that can be sent. So how many number of frames that can be able to send, that keeps track of the frames. That is the sender window. It maintains the window size. So here the window size is what? 4. Number of frames he wants to send, 8 frames he wants to send to the receiver side. But the window size is 4 means it capable to transmit 4 frames at a time simultaneously. So here the number of frames are 8. He wants to transmit the 4 frames as the window size is indicated. So he sends, the current window is what? 1, 2, 3, 4. Now these 4 frames are to be sent. So sender sends frames 1 to 4. Sender sends 1 to 4 frames. Now the receiver accepts frames that lie within its receiving window. Within its receiving window. After receiving them correctly, it sends an acknowledgement. So that means 4 frames have been received. 4 frames have been received. Like that, he sends an acknowledgement to the sender side. The receiver sends an acknowledgement to the sender side as that 4 frames are received. Now the third one is what? Acknowledgement. So an acknowledgement informs the sender that the receiver has successfully received a frame. So sender frame 1, receiver acknowledgement 1. So here the working of sliding window protocol is what? The same thing. The total frames are available 8. Window size is what? Frame. The sender sends 4 frames. So now F1, F2, F3, F4 are sent. Now receiver, after receiving all the frames, receiver sends an acknowledgement to the sender side. The receiving 4 frames are received successfully. So here the receiver sends an acknowledgement ACK 4. That means ACK 4 means frames 1 to 4 have been received successfully. So that the sender wants to send another 4 because the frames contains 8, right? So he sends the window. He sends the frames in through the window. The sender slides the window. So initially window having 1, 2, 3, 4. After acknowledgement received from the receiver side, remaining window 5, 6, 7, 8 or the frames are available to transmit. So he takes that 5, 6, 7, 8 frames and the sender now transmits that frames 5 to 8. In spite of sending each and every frame and waiting for each and every acknowledgement, for each and every frame, we can through this window protocol, we can able to send multiple frames at a time. Instead of sending one single frame, we can send multiple frames simultaneously. So simultaneously is based on the window size. So based on the window size, we can able to transmit the frames. So after receiving that all the frames, receiver sends an acknowledgement. That 4 frames have been received. So that the sender can able to send remaining available frames. So this is the main protocol working principle in the sliding window protocol. The advantages, if you see the advantages, it improves bandwidth utilization because no need of waiting for each and every frame. Each and every acknowledgement. So the bandwidth is properly utilized. bandwidth is properly utilized, channel is properly utilized, because number of frames have been sent. If we send more number of frames, again it is a problem. If we send more number of frames, again it is a problem of collision. The channel having the smallest capacity, if you send more than number of frames, the channel may be decreased, the channel size may be decreased, right? So that is one also problem. But in the sliding window protocol, it takes based upon the window size. So that gives, the size of the window gives the number of frames that you want to send. So now multiple frames are transmitted simultaneously. So proper bandwidth utilization is done, and multiple frames also transmitted simultaneously. So by doing these all, increases the throughput, and also the reduces the waiting time. So bandwidth utilization properly, and the time wasting is not also done. So that reduces waiting time. So based on these two, the throughput is increasing. So provides a flow control between sender and the receiver. It provides a flow control, proper flow control between sender and receiver. So this is the way of working of sliding window protocol. And the next protocol is what? Go back in ARQ protocol. So automatic request, repeat request protocol. So go back in ARQ. ARQ stands for what? Automatic repeat request. Automatic repeat request. It is also an error control protocol based on the sliding window protocol. So in the sliding window protocol, what we have done, we can send multiple frames at a time. So frame 1, frame 2, frame 3, frame 4 are simultaneously transmitted to the receiver side. If any error occur in one frame, so out of these 4 frames, if any error occur in one frame, the receiver discards that frame and all following frames. Receiver, suppose if any frame 3 is having an error, the receiver does not receiving this frame 3 and frame 4. He sends an acknowledgement that only received acknowledgement to up to frame 2, he receives an data. He receives the frames. So he sent an acknowledgement that I received only frame 1, frame 2. Because frame 3 is error, so it discarded along with the frame 4 also. So here see, the receiver discarded that frame and all following frames. Even if some were received correctly, also, it stops that remaining frames. The sender retransmit the erroneous frame and every subsequent frame in the current transmission. The sender has to retransmit that remaining error frames as well as the remaining frames. So what is the need of go back? So in the sliding window protocol, all frames are to be transmitted, but out of these all 4 frames, if any frame is error control, then the other frame is also not able to transmit, right? So see here, the frame 1 is forwarded, frame 2 is forwarded, but frame 3 is lost, and frame 4 is forwarded, frame 5 is forwarded. So out of these 5 frames, the frame 3 is error, although frame 4 and frame 5 are arrive correctly, they are discarded. Because if the frame 3 is missing, then frame 4 are also not able to receive properly, right? So because the frame 3 is missing or corrupted, so that thing that frame 4 and frame 5 also may be corrupted or may be discarded. So that is the way, the go back in protocol sends an acknowledgement that up to frame 2 I received, and I didn't receive frame 3, frame 4, frame 5. So again it asks the sender to retransmit from frame 3 onwards. Again it asks the sender to retransmit frame 3, frame 4, frame 5 onwards. So working principle. So example, window size is what? Frame. The sender transmit frame 1, frame 2, frame 3, frame 4. So 4 frames he wants to send. Suppose if in the middle channel the frame 3 is lost, so receiver receives frame 1, frame 2, frame 3 is lost, frame 4 also transferred. So the receiver sends an acknowledgement that only for frame 2, only for these frames, because the frame 3 is lost. So after losing that frame 4 also discarded, because it does not believe that frame 3 is lost, frame 4 is received, right? So that is not, it is observing that frame 4 is received properly. So the sender retransmit that frame 3 and frame 4 because the frame 3 is lost. So it asks sender to retransmit the frame 3 and frame 4 again. So that sender retransmit that frame 3 and frame 4. This is the why the protocol is called as go back N. The sender goes back to the erroneous frame and retransmit from the point onwards. Retransmit from that point onwards. So whatever the frame has been lost, go back to there and retransmit the remaining frames. Retransmit the frames from the lost frame. That is the way the receiver send an acknowledgement to the sender. So please retransmit the frames where you lost, from where that is discarded. The step by step here, the window size is what? 4, and sender transmitting 1, 2, 3, 4 frames. Now receiver receives that what? Frame 3 is lost. So receiver receives frame 1, frame 2, frame 3 is lost, and frame 4 is received, but it will be discarded. It will be discarded because the frame 3 after losing the frame, it does not believe that frame 4 is received properly. So that is why frame 4 also discarded. So now frame 3, frame 4 discarded. Receiver sends an acknowledgement that frame 1, frame 2 are received. Frame 1, frame 2 are received. That ACK2 indicates that what? Frame 1 and frame 2 were received successfully. Only these two frames are received successfully, and frame 4 received but not received successfully because of the proper loss of the frame 3. Right. So this indicates that frame 1 and frame 2 were received successfully. And step 4, receiver sends an acknowledgement to the sender that frame 2 up to frame 2 it receives successfully. So sender retransmit that third and fourth frames because receiver sends an acknowledgement that I received only up to frame 2. So please retransmit the remaining 2 frames, that from 3 onwards, that from frame 3 onwards. So sender retransmit that third frame and fourth frame. Now the receiver now receives them properly. Receiver now receives them properly. So that acknowledgement 4 sends. Acknowledgement 4 sends. That means frame 3, frame 4 also received successfully. So transmission continues with the next window. Next window, the size. The frames contains number of frames 1 to 12. The first size is over, second size is over, third size is over. Like that, the transmission also continues with the next window up to the end of the frames available in the windows, right? The advantage of this one is what? Reliable data transmission. Reliable data transmission. That means it uses channel as well as it uses proper time utilization also. And simple receiver design. So receiver also participating that each and every acknowledgement it has been forwarded. If any errors are there, it has been forwarded that up to the before error frames are received. And it detects and recovers from transmission errors also. Uses cumulative acknowledgements, reducing acknowledgement overhead also. So by sending each and every frame received acknowledgement, it reducing that acknowledgement overhead also. So these are the two protocols are using for control flow and error control flow. So one is what? A sliding window protocol, and other one is what? Go back and ARQ protocol. The differences between sliding window and go back and ARQ protocol. So differences are, the features of these protocols are what? Purpose, reliability, retransmission, acknowledgement and efficiency, receiver behavior and main objective. The sliding window protocol is what? The purpose of this sliding window protocol is flow control, and go back is what? Flow control plus error control mechanism. And reliability is what? It does not handle errors by itself. Reliability is nothing but what? It does not handle errors by itself. But go back and ARQ is what? Handles transmission errors also. And retransmission here, the not required. Sliding window protocol not required because all frames have been forwarded. But in this go back and erroneous frame and all subsequent frames are retransmitted. So wherever the frames are lost, from there it has been forwarded. An acknowledgement used to slide the window. So acknowledgement receives after sliding the window, and here cumulative acknowledgement receives. And the efficiency high in error-free channels. So it provides high efficiency in error-free channels, and it reduces efficiency when errors occurs due to the retransmission process, it occurs an errors. And receiver behavior, accept frames within the window, discard all frames after the first erroneous frame. So if any errors are occur, it discards all the frames after the first erroneous frame. And efficient use of bandwidth, here channel utilization properly, time utilization property. So efficient use of bandwidth, here reliable delivery of frames. So these are all the differences between the sliding window and go back in ARQ protocol. I hope all of you understand. Thank you.